A silent forest of steel giants rises from our landscapes. A shimmering sea of blue panels blankets deserts and rooftops. This is the promised land of green energy, a clean, sleek future powered by wind and sun. We're told it's the ultimate solution, a moral imperative to abandon the dirty fuels of the past. But what if this green revolution is built on a hidden foundation of fossil fuels? What if the very machines designed to save our planet carry a hidden environmental price tag so steep that it challenges their very purpose? This isn't a story about denying climate change. It's a story about complexity, about unintended consequences, and about asking the difficult question the mainstream narrative often ignores. Is our rush to go green actually sustainable? Strap in, because the reality of renewable energy is far messier than you've been told. The concrete giants, the hidden life of a wind turbine. Picture a modern wind turbine. It's a marvel of engineering, soaring over 400 feet into the air, taller than the Statue of Liberty. But its true story begins not in the sky, but deep underground. A single industrial wind turbine requires a foundation of over 1,000 tons of reinforced concrete and steel, sunk 30 feet or more into the earth. That's enough concrete to build over 30 family homes. To transport the colossal blades and tower sections, often from overseas factories, requires a convoy of diesel-guzzling trucks and ships. The installation itself demands massive cranes that run for days on petroleum. And here's the first uncomfortable truth. Who is building these monuments to a post-oil future? Often, it's the oil companies themselves. Giants like BP, Shell, and Total Energies are among the world's largest investors in renewable projects. This isn't necessarily hypocrisy, it's business. But it reveals that the green energy transition is not a hostile takeover. For many, it's a strategic diversification, a way to profit from both the old world and the new. The energy debt, when clean tech isn't carbon neutral. This leads to one of the most critical yet overlooked concepts in green energy: embodied carbon. This is the total greenhouse gas emissions generated from a product's entire life cycle, from mining the raw materials, manufacturing the components, transporting, and installing them. A peer-reviewed study published in the Journal of Cleaner Production calculated that for a wind turbine to pay back this carbon debt from its construction and become truly carbon neutral, it must operate for between 6 months to a year, depending on the energy source it's displacing. This seems manageable. However, this calculation assumes optimal, consistent wind and a smooth 20 to 25-year lifespan. In reality, many turbines, especially in less windy regions or those plagued by mechanical issues, may struggle to reach this break-even point within their operational lives. When a turbine fails prematurely, the environmental ledger can remain permanently in the red. The solar shadow, the dark side of sunshine. If wind power has its challenges, solar energy is often presented as the pure, simple solution. But the creation of a solar panel is an intensely industrial and chemically complex process. The primary material, high-purity silicon, is produced in energy-intensive furnaces heated to over 2,000 degrees Fahrenheit, often powered by, you guessed it, coal or natural gas. Then there are the rare earth elements and toxic materials. While many panels use silicon, certain high-efficiency types rely on elements like cadmium and lead. The mining and processing of these materials create hazardous waste. A 2017 report by the International Renewable Energy Agency, Irena, projected that by 2050, the world could be facing up to 78 million metric tons of solar panel waste. Unlike the glass and aluminum in your recycling bin, solar panels are complex laminates that are notoriously difficult and uneconomical to recycle, risking a tidal wave of toxic e-waste in the coming decades. The battery bottleneck, lithium's dirty secret. The Achilles heel of both solar and wind is their intermittency. The sun doesn't always shine, and the wind doesn't always blow. The proposed solution? Giant battery farms like those championed by Tesla. These lithium-ion batteries are the heart of our green future, powering everything from our phones to our cars to the grid itself. But the cost of lithium is extracted from the earth at a staggering environmental price. The lithium-ion battery for a single Tesla Model S requires approximately 12 kilograms of lithium. The primary source of lithium is from brine deposits in the salt flats of South America, in countries like Chile and Bolivia. The extraction process is water-intensive, requiring roughly 500,000 gallons of water per metric ton of lithium. In already arid regions, this is draining precious aquifers, devastating local farming communities and ecosystems. A 2020 study in Nature highlighted the severe environmental and social issues associated with lithium mining, including soil degradation and water scarcity. The green future, it seems, is thirsty. The Petroleum Lifeline. Why we can't quit cold turkey. This brings us to the ultimate paradox. Our entire green energy infrastructure is built by, transported by, and often maintained by machines that run on petroleum. The mining trucks that extract the iron ore, diesel, the container ships that transport the components from China, heavy fuel oil, the tractors that maintain the land around solar farms, diesel, the plastic polymers that protect wind turbine blades and solar panel wiring, petroleum-based. Petroleum is not just gasoline. It is the foundation of modern civilization. It's in the asphalt on our roads, the plastics in life-saving medical devices like 4-bags and syringes, the fertilizers that feed billions, and the pharmaceuticals that keep us healthy. As energy expert Vaclav Smil has meticulously documented, there is currently no single energy source, nor a combination of renewables that can replace the dense, portable, and versatile power of fossil fuels at the scale required by our global civilization. We are attempting to use the tools of the old world to build the new one, and in doing so, we remain inextricably linked to it. Facing the reality, a problem without an easy answer. So where does this leave us? This investigation serves not as an obituary for green energy, but as a crucial intervention, a call to trade starry-eyed idealism for clear-eyed realism. The monumental challenges of material scarcity, looming toxic waste, and the massive hidden energy embedded in these technologies are not mere footnotes. They are central pillars that could determine the success or failure of the entire transition. The true path forward demands a fundamental shift in our approach, a concerted global push to pioneer advanced recycling, creating a circular economy that can truly close the loop. It requires radical, unflinching honesty about the total environmental cost of our choices. And most critically, it compels us to aggressively pursue next-generation energy solutions, like nuclear power, which hold the potential to provide the dense, reliable foundation that renewables alone cannot. The green revolution was never a simple switch we could flip. It is a complex, messy, and Herculean transformation of our civilization's very bedrock. To have any hope of success, we must first have the courage to be honest about its true and immense cost. The future of our planet is the most important discussion we can have, but it has to be an honest one. What's your take on the green energy dilemma? Share your thoughts below, and if you resonate with this video, please like and subscribe for more unfiltered analysis.